So now that we have discussed the concept of the significance of uniform mass distribution and the comparison between uniform and non-uniform mass distribution, let us now focus completely on solving this question in a very detailed structure. Okay. So usually the if you were to ask for the basic steps involved in solving this, I would say step number one would be to choose the origin. Step number two be to find out the individual COM, and the third step would be to calculate coordinates of the overall COM. Right. So this is what we have for every figure, for every question, which is based to find out uh, on based on finding out the center of mass. Now, how do we approach this question? So we have been given a figure here. So here we'll use the composite body technique and using the method of addition of figures. The next set of solutions we'll discuss about composite figures, but on based on subtraction. Now, how do we add figures? You will divide this complete given shape, given structure into three shapes, three composite shapes. One would be structure 1, the large base rectangle. 2 would be the rectangle number 2, which is close to the, which has one edge on the y axis. And then the third figure, which again is a rectangle, the right one on the top. Okay. And origin is given to be this point here. So step number 1 is complete. Now, what is step number 2? Step number 2 is to find out individual center of mass, which means we'll have to find out center of mass of figure 1, center of mass of figure 2, and then center of mass of figure 3. How do we find out center of mass of figure 1? Center of mass of figure 1 would be the jaw. Okay, before we go to center of mass, let us first convert this coordinates into the length. So for the first figure, which is the base rectangle, the large base rectangle here, the coordinates are 0, 0 and 3, 0, which translates to the length as 3 units along the width, and it is given to us that this coordinate here is 2, 1, right? Sorry, this would be 3, 1. So we have the 3, 2, right? Oh, my bad. We have 3, wait, did we have a mistake here? Okay, yeah, it's 3, 1. So the width here would be 1, right? So we have a rectangle which has length 3 and width 1. Now, what is the coordinates of center of a mass of a body which is a rectangle in shape of width 3 and of height 1? The center of mass of the rectangle is width by 2 and height by 2, which basically is the point of intersection of its diagonals, and by symmetry of the figure it is w by 2 and h by 2. The width is 3, so it is 3 by 2. H is 1, so it is 1 by 2. So the center of mass of this rectangular plate is 3 by 2 and 1 by 2. Now, what is the second step? The second step is to find out the center of mass of this figure with respect to the origin. And how do we find it? So second step is to find out the position of coordinates of center of mass of a rectangular plate with respect to origin. Now what should come into picture? Now the picture of y-axis and x-axis should come, wherein we'll place the given figure and find the coordinate of this point here. Okay, and how will we do that? Let's see. So let us say that the center of mass of this large rectangle is C1, whose coordinates are x1, y1, and it is the position of coordinates of center of mass of rectangular plate with respect to origin, the origin being 0, comma 0. Now, what is this point? This point is otherwise 3 by 2, comma 1 by 2. And since this is from the origin, the coordinates of x1, comma y1 would be, the coordinates of x1, comma y1 would be, what will be x1? x1 will be distance, would be this distance, right? Starting from, let me just write down these values. Maybe that will make more sense. So x1 will be this distance, C, 0 to A, OA. And how will you measure OA? You will measure OA like this. So this is the measure OA, right? And what will be the measure OA? The measure OA is equal to this length, which is 3 by 2. So x1 here is equal to, x1 here is equal to 3 by 2. Similarly, what is y1? y1 would be this distance, right? y1 would be this distance. Excuse me, yeah. So y1 would be this distance, which is half of this height, which again is equal to 1 by 2. I know things are a bit confusing here. Yes, because we're doing it the first time, it would be. And the second figure onwards, things will become very clear to you. Okay. So what did we do so far? We found out the center of mass, coordinates of center of mass of the first figure, x1, y1 with respect to origin. Okay. Now we have the second figure, which again is a rectangle of width 1 and of height 1, which means the coordinates of center of mass of rectangular plate of this plate, coordinate of mass of this rectangular plate will be again by virtue of its symmetry, width by 2 and height by 2. Width is 1, height is 1, so we'll have 1 by 2 and 1 by 2. Okay, are we done? No. Now we should be finding the coordinate of center of mass of rectangle with respect to the what? With respect to the origin. So now we will have to place the same figure and then find out the coordinates. So now we have C2, which is the center of mass of this rectangle with respect to origin. The coordinates being x2, comma y2. And how do you find out x2, comma y2? You'll have to find out x2 by looking at this distance. Let us name that distance OA. So what is OA? OA corresponds to this distance over here. So OA is equal to half of this width of the triangle, which is again 1 by 2, right? What is y2? y2 is the distance from this axis over here, right? This x-axis over here. So it is this much distance. How do you find out y2? See, y2 is actually a combination of two lengths. One, starting from this x-axis, it goes up over here. That is one length. And then we have the length over here. So maybe we can name it as ABC. So what is y2? y2 should be equal to AB plus BC. How much is AB? We know that AB is equal to AB is equal to 1 by 2. How much is BC? The coordinate here is 1. So the length is from 0 to 1, which means it is half plus 1. Therefore, is equal to 3 by 2. Therefore, coordinates of mass of C2 becomes x2, comma y2, which is equal to 1 by 2 and 3 by 2. Thereby differentiating the center of mass of this rectangle alone, which is 1 by 2 and 1 by 2. So we have center of mass of the second figure alone being 1 by 2 and 1 by 2, and then center of mass of second figure with respect to origin as 1 by 2, comma 3 by 2. That is the difference here. Okay. Right. Now, I know some of the things which were not clear in the first section, first figure, are clear to you now. But now you have some other problems which were not earlier present. And both of them will become clear in the third figure. Let us see how. So we found out the center of mass of first figure, which is x1, y1, of second figure, the second rectangle x2, y2, and what is left to find out is x3, y3. How do you find out x3, y3? Again, we have a rectangle with W is equal to 1 as the width, height is equal to 1 as the height. So coordinates of mass of center of mass of a rectangular plate by virtue of being a symmetrical figure by will be its geometric center, which is the point of intersection of its diagonals in this case, which is W by 2 and H by 2, which is 1 by 2 and 1 by 2, right? And this is the center of mass of the third figure, but not with respect to origin. And how do you find out with respect to origin? So now we have center of mass of third figure, which is with respect to origin. How do we find that? See, x3 would be this distance, right? Let me name that. So we can write this as O, A, B, and C. So x3 is the sum of OA plus AB plus BC. How much is OA? OA, this complete length here is 1. It is given in the question. AB again is equal to 1, which is given as well. How much is BC? BC should be the x coordinate of the center of mass of this figure, which is 1 by 2. Therefore, it becomes 1 plus 1 plus 1 plus 1 plus 1 by 2, which is, so this complete distance OC becomes 1 plus 1 plus 1 by 2, which is 2 plus 1 by 2, which is equal to 5 by 2. So the coordinate of x coordinate here becomes 5 by 2. Now let's see what happens with the y coordinate. So let us say this is CD. So what is the y coordinate? What is y3? Y3 is the distance of this point C from the x-axis. So from the x-axis, if we measure, we see a couple of lines here. Which are they? We can see one line which starts from D till over here. Maybe we call it as E. And then we have another line which starts from E to C, right? And how much is D to E? D to E here is 1. And how much here is CE? CE is half of this width, which is 1 by 2. Therefore, if I were to write what is CD, CD is equal to CE plus ED, which is equal to half plus 1. 1 plus 1 by 2 is 3 by 2. And the coordinates therefore are x3, y3 is equal to 5 by 2, 3 by 2. Now we have all the given values. Now we have determined all the three center of mass. What? Center of mass of the individual figures with respect to the origin, which gives us x1, y1, x2, y2, and x3, y3. Now what can we do? Now what we can do is we can find out the value of the masses of this figure. So if you have given, if you have written notes for the previous solution, then we have very clearly stated that for equal areas, the masses will be equal when the given plate is uniform in nature, which gives us the mass of the larger rectangle as 6, the smaller as 2, and the smaller as 2. So the left and the right hand top side of the rectangles will have 2 kilogram mass, and the bottom larger rectangle will have a mass of 6 kilogram. Okay, so we have m1, m2, m3, x1, x2, x3 corresponding y1, y2, and y3, which means we now have all the required inputs for calculation of center of mass of the combined object, which is m1 x1 plus m2 x2 plus m3 x3 by, sorry, I missed this here, should be by m1 plus m2 plus m3. What is m1? 6. x1 is 3 by 2, so we have 6 into 3 by 2 plus m2 is 2, x2 is 1 by 2, 2 into 1 by 2 plus m3 is 2, m3 is 2 into x3 is 5 by 2, so it is 2 into 5 by 2 by m1 plus m2 plus m3 is 6 plus 2 plus 2, which gives us the value as x bar is equal to 30 by 2 by 10, which is, wait, 6 into 3 is 18, 18 plus 2 is 20, 20 plus 10 is 30, 30 by 2 by 10, which is 15 by 10. Okay. Now, similarly, what would be the y coordinate? Y coordinate of the center of mass of the combined figure will now be equal to m1 y1 plus m2 y2 plus m3 y3 by m1 plus m2 plus m3. 6 plus 2 plus 2 is 10 in the denominator. m1 is 6 into, okay, maybe 2, to just to make sure that you don't get confused here. I'll just erase out x1 now because we don't need x1, right? All we need is y1, y2 and y3. Yeah. So m1 into y1, 6 into 1 by 2, m2 into y2, 2 into 3 by 2, m3 into y3, which is 2 into 3 by 2 again. So we have 6 plus 3 into is 6, 3 2 into 6, 6 plus 6 is 18, 18 by 2 is 9, and what we have y bar is equal to 9 by 10. Therefore, the coordinates of x bar and y bar are 15 by 10 and 9 by 10 respectively. So the ratio of x bar and y bar becomes 15 by 10 by 9 by 10, which is equal to 15 by 9. And if you read the question, would be asked to find out is the center of mass coordinate is given to us as n by 9, and therefore the value of n should be equal to 15. Okay. So let me just summarize the steps here. So fix the origin. That should be step number 1. Find out the individual center of masses. Calculate the individual center of masses position with respect to origin. With respect to origin, you then have x1, y1, x2, y2, xn, yn, and then you can find out the formula for x bar, apply the formula for x bar, y bar, which will be equal to m1 x1 plus m2 x2, etc., divided by m1 plus m2. Okay, so that was all the ways of looking at this question. I think we did a very short explanation, and then we tried it using the density method, second one the area method, and third one using the mass method. And we've seen not just the direct application of the formula, we also seen the derivation, the way we have derived these formulas. So that marks the end to this question. Now we have the second question in JEE Mains 2024, which is based on displacement of center of mass. Let's go through that now.